So we are going to quickly review, if you think about it, we had 7.1 and 7.2, okay? So 7.1, section 7.1 and 7.2 were what we were already tested over. 7.3 is the new stuff we'll move into next week, okay? That'll move to next week. So if we could just really quick review that would be kind of what we would expect or would want to do today. Okay, so let's look at the top questions. A number that describes the whole population is known as a? Okay, I like that. What describes the whole population? Parameter. Exactly. Good. That would be the first one. So the top one is a parameter. Okay? So that top one up on top, first one is parameter. Okay? Someone different now, that other than Maddie, tell me what is a number that is calculated from a sample? Morgan? Statistic. Good. Yeah, that's what we're looking at. Okay? So that second one, we're going to put statistic. We'll look at notations in a second, just as a review. All right, someone different now tell me, number 3, we always use a blank to estimate a blank. Let's give it, Campbell.
Sample to estimate a population.
Yeah, so a sample to estimate a population. I like that. And if we're talking about the actual number, we would say that it's a statistic to estimate a parameter, right? So you could say this, really what we're looking for, too, is a statistic to estimate a parameter. Okay? Now, if you do have questions or if you're like, man, coach, could you remind me? Just stop me, okay? Does this make sense so far? We're good? Okay. The next thing, it says this, in section 7.2, if you remember that far, if you don't, that's okay. We use a blank to estimate a population proportion. What did we use? This is true. This is true. What type of distribution? I like that. Sample what? Good. And do y'all remember what type of sample? We focused on one thing, a sample proportion. Remember that? Okay. So on the 7.2, say we used a sample proportion to estimate a population proportion. Okay? A sample proportion to estimate a population proportion. That was 7.2.
So I know we're doing this unit again. Are we taking another test on the whole unit?
We are. However, you'll notice that 7.1 and 7.2 encompass most of what we did in 7.3. There's a few different tweaks, but it really is kind of going back through, because if you look at what is the number one chapter, the most important chapter in statistics, it's chapter 7. So we missed 7.3, which I'm kind of glad about, because we're just going to re-emphasize, go through, review, and then we'll take that one more time. We'll do that a week from this coming Monday.
So we have another chapter. Will we have a quiz?
No quiz.
No quiz.
No quiz at all.
Just test.
Just
over
test.
all of it.
7.1 to 7.3. Yes, correct. Yes, sir.
Can you explain sample proportion real quick?
Yeah, that's a good question. So if you remember, I'm trying to think of one of our activities, and it's slipping my mind here. Yeah, so if I remember right, when we flipped the coin, heads or tails, right? We said, what is the proportion of heads when I flip the coin, right? A sample proportion is, out of the population, I take a sample, right? And depending on what I get in my sample, right, that proportion, each dot represents one specific value within that entire sample. So maybe this will be, let me do this. Let me get this. Okay. Now, remember we also talked about a sample compared to sampling is what? What's the difference?
A sample is just like one, and
Good.
something is like multiple samples.
Correct. That's exactly right. So in this one, this is more of a sampling distribution here. Okay? Sampling. But this is a good example of a proportion, right? Remember, each of these dots were I had y'all flip the coin. I forgot how many times. I don't know if I put it there. Let's say that I had you flip it 20 times, right? And I said, okay, calculate the proportion of heads. Each dot that you see up here is one of your results. So let's say this one right here was 0.5 was that proportion. We're saying that that individual, when they flipped it 20 times, got heads 10 times, right? So this right here would be a sample, or sampling really, sampling distribution related with proportions. Does that make sense a little bit? So this is what we had talked about in 7.2. Okay. See if there's another one. I don't see another one. Down here is what we're going to look at in 7.3. So we're going to go do the same exact stuff. The only difference is we're going from a sampling proportion distribution to now a sampling of the means. So we're going to use means instead of a proportion. Okay? Do you want me to talk about that real quick, the difference? Real quick. So the heads, right? We flipped it and we said what was the proportion of heads out of 20, right? Now we're going to move towards not just that. We're going to say out of, let's say, all of GAC, what is, comparing the ACT scores, what is the mean ACT scores? Now we've moved from a proportion of how many, what was the percentage out of 20 to what is now the mean ACT score. Does that make a little bit more sense? A little bit? So that would be more of what we would talk about in 7.3 down here. I think this was the number of siblings that we did, if you remember way back when. That would be the difference between 7.2, which is proportion. Does that help you a little bit?
Yeah.
Okay, awesome. All right, so let's do the next one. In section 7.3, we're going to use a sample mean to estimate a population mean. We're not going to get into that today, but we're going to use a sample mean to estimate a population mean. Okay, now what we're going to do is this right here. So in doing this, why I love this is this compares the two. Okay, so this would be 7.3, and this right here was 7.2. Sample proportions down here. Okay. All right. So question: how do we represent the parameter in terms of the notation?
Okay.
P. Exactly. Good. Thank you, Matthew. What is someone different who has not gotten one yet? What is the statistic notation? Close. Do you know where X bar would go? X bar relates to mean, right? So I am not doing this column yet, but if I did, X bar would be there.
So then
Oh,
mu
so that
would
would
be.
be
Correct. Yeah, this would be mu, right? Good. I like that, Emily. What would be this one, Emily? Do you know for the statistic? We have P and P. Let me see if I've got it up there. P hat. That's exactly right. Okay? P and P hat. Good. That was for X bar and mu. Nicely done. Okay? Okay. So, we have this, right? We have these two. Let's talk about number 3. Sampling distribution. Okay? When we draw this, a sampling distribution, if you remember, even if the population is not normal or approximately normal, we can say that if the sampling distribution is large enough, it'll ultimately look how?
Approximately normal.
Approximately normal, right? The larger the samples that we get from this, the closer it gets to normal, right? Right? This is just review, but the larger the sample size, what happens?
Less variance.
Yeah, less variability, right? Hopefully this will help, and we're going to keep emphasizing this. So right here, I want you to draw this, kind of a normal distribution, okay? So this is a sampling distribution for P hat, okay? All right, and then this down here is going to be P. I'm going to show you why in a second, okay? So that mean value is going to be P. Okay, so if you remember, when is the sampling distribution approximately normal? This is a formula if you remember this.
Is it the 10%?
Yes, 10% condition. I like it. All right. Max, I heard you say something. Were you saying something?
It's like 1 over 10.
I like that. You're all over it. You're all over it. We're going to say this. N times P is greater than or equal to 10. Okay? And, so this is the true statement. We also got to do the, I don't want to say not true, but it would be the counter of that. N times 1 minus P has to also be greater than or equal to 10 as well. We call that our 10% condition. Okay? Again, this shows that this value or this sampling distribution is approximately normal. Is this contingent on what the population looks like?
contingent? Yes.
It is not. It is not. So even if it's skewed right or left with the population, if the sampling distribution follows this 10% condition, we could say that it's approximately normal. Okay? Perfect. Okay, next one. What is the mean of the sampling distribution?
P.
Correct? Yeah. So we would say this. I like this better. The mu of p hat is equal to p. That looks a little weird. Could someone just kind of talk me through what does this mean?
The mean of the projected is going to equal the parameter, or the mean of the statistic is going to equal the parameter, the whole population.
Yes, that's exactly right. So the mean of my proportion of my statistic is equal to my parameter. Yeah, that's perfect. That's exactly right. That's why we put p here. Okay? That's why we put p here, because that is the same thing as the mean of p hat. Okay? All right, let's keep going. What is the standard deviation of the sampling distribution? This is way. So this is the standard deviation of the sampling distribution within our proportion, right? Talking proportions here. That's equal to what?
Square root of p times 1 minus p over n.
You have to memorize that.
It's on the formula sheet.
Yeah, it's on the formula sheet. So remember that. It is on the formula sheet. Okay? These two here, in fact, I'll kind of help you here, just so you've got it. This one is not on the formula sheet. Correct me if I'm wrong, but from what I remember.
I don't think 10% was.
This is not. This I think
That
might be.
is.
Yeah, that is.
is.
This is not what we're going to talk about right now. Okay. What condition must be satisfied in order to use the above formula? So we got to establish something. Say again. CLT, good.
What does that mean?
Central limit theorem.
And what is the formula for that? Anybody else that has not gotten one yet today?
James. I really don't.
It's called CLT, central limit theorem.
Yeah, not really, but just take guesses. I don't think it's on
Is
there.
it?
Like
It must be that was
There's like a
Equals
capital
Right.
N.
50
You gotta use the
or less
capital
than
N.
Say that again.
You just use the capital N.
Yes. So we're going to say 1/10
that.
of my big N, okay, is less than or equal to, greater than or equal to, I said that wrong. N is less than or equal to 1/10 of my population of N, okay? So the little n has to be less than 1/10 of the population.
The 10% condition is not on the formula sheet.
Yeah, that's why I circled it.
Yeah, this
That's
one
why
right
I
here?
circled it? Alright. I
These
actually
two are
circled it
not.
because it was on. Never mind.
Yeah, you're good. All right, so these two right here, we're good. We're good on, right? Okay? Now, this next part, the formula for a z-score, really you have two options, right? What's option one you could do on a FRQ? Yeah, you could definitely, yes. You could do that, or you could go to normal CDF, right? So I'm going to put normal CDF here, and I'm going to guess that you know kind of what's expected on that. We've done that a lot first semester. If you need some help on that, let me know. But you can do that, or the formula for this is Z equals
X minus p.
Or P minus
P
P
minus
hat.
p hat.
P minus P hat, good, because we're talking about proportions, right? All over my standard deviation, which is?
The square root of p times 1 minus p over n.
Correct. Now that looks really, really complicated there. But this right here, all it is x minus x bar, remember that? Divided by my standard deviation. We're just putting that in the context of proportions that are here, okay? Does that make sense? The only thing I would say is if you use normal CDF, that's perfect. You've got to establish context, though. You've got to establish what it is, write in the values, and then you could write your answer in. That's fine, but you've got to write and show that work that's there, okay? Now, questions about any of the stuff that I talked about from that left column? Any questions at all? Okay, I think the bottom, chapter 6, binomial stuff right here, we talked about it first semester. I'm not going to go into that too much right now. That is not chapter 7, but sometimes within an FRQ, you could do either the binomial distribution or you could do what we just did right here, okay? You'll get a little bit of a different answer, but that's okay as long as you follow the same pattern and procedure, okay? What's a binomial distribution again?
Yikes. Two number distribution.
Two outcomes.
Two outcomes. Why would this, like, when I toss heads or tails, why would this be a binomial distribution? Technically two.
There's only two results.
It's like it's either heads or tails. They're all independent of each other. There's a set number of trials, which is 20, and then shoot, so that's or
Success percent,
rates, which is
It's the same at 50.
P, which is 50.
because it's 50 each time. Does that make sense?
Yeah.
So if that follows true, you could do either one. Okay? You'll do either one and get that credit. Okay. So with this being said, your homework is this. Okay? Which is, I'm not checking anything for next Monday, but as you prepare, this is going to help you. I would read 7.1 and 7.2 to just kind of get your head flowing with it. I'm not going to quiz over it, but that's just something I would do. The second thing I want you to do is go to your FRQs. We're going to get started on this. In your groups, I want you to do the following, okay? So you're going to go to your FRQs. I'm going to pull this one up. And I'm sorry, for some reason, this didn't get a number or a label on it. And that's my fault. I'll try to tweak that for next time. But right here, it says, imagine a very large candy machine. I think it is on the second page. Page 7? Sweet. Thank you very much. Number 7 right at the top, okay?